So let's take a look at an example that's a little more complicated. This problem says use the limit definition of the derivative to find the instantaneous rate of change of f of x at x equals to 3. So just a quick reminder, well, a couple of reminders. Anytime we want to find the instantaneous rate of change, what we're looking for is we're looking for f prime of x. And that's given by the limit as h approaches 0 of the difference quotient, which is f of x plus h minus f of x all over h. So this is what we're looking for. Instantaneous rate of change is same as the slope of the tangent line at any given point. Okay, so we have to find out the difference quotient first before we can take the limit as h approaches 0. So let's break this up into three parts. F of x plus h, and then f of x, and the whole thing together. So let me first find f of x plus h. Now for f of x plus h, we need to find out the expression when the input is x plus h. So that means every time I see an x, I'm going to replace that x with an x plus h. So if this is my input, every x gets replaced with x plus h. So I have, instead of 5x squared, I have 5 times the quantity x plus h squared. Instead of 7x, I have 7 times x plus h, and then I have plus 2. Now when you square something, you have to multiply it by itself. So x plus h squared is x plus h times x plus h. Now you can do some algebra, you can FOIL this. So if you FOIL it, we're going to get x squared, and then you have xh and xh, that gives you a 2xh, and then you have an 8 squared. And then you would distribute the 7. So we have 5 times the quantity x squared plus 2xh plus 8 squared. And then if you distribute the 7, we have 7x plus 7h plus 2. Now we distribute the 5, and that gives us 5x squared plus 10xh plus 5h squared. Okay, that's the first part, just finding the f of x plus h. Now f of x is given to us as 5x squared plus 7x plus 2. That's just a given function. If I put it all together to find the difference quotient, I have f of x plus h, which is this whole big thing. So parentheses 5x squared, 10xh, 5h squared, 7x, 7h2, minus, make sure you use parentheses, 5x squared plus 7x plus 2. The reason I say make sure you use parentheses is because now we can distribute that negative. So if I distribute the negative, I have a negative 5x squared, I have a negative 7x, and I have a negative 2. Then I combine my like terms, so the 5x squared and negative 5x squared cross out, 7x and negative 7x cross out, 2 and negative 2 cross out. So I'm left with 10xh plus 5h squared plus 7h, and all that is divided by a monomial h, so all three terms individually will get divided by h. And now if I cross that out, it's going to give me, so this is going to cross out, gives me 10x. 8 squared over h is going to be h, and then the h is crossed out, so I have just a 7. That is not my derivative, that's just the difference quotient. To find the derivative, or f prime of x, I need to take the limit of that as h approaches 0. So if I take the limit of 10x plus 5h plus 7 as h approaches 0, I'm going to use direct substitution and replace the h value with 0, which gives me 10x plus 7. So that is the derivative of 5x squared plus 7x. But we don't just want the derivative, we want the derivative at x equals to 3. So at x equals to 3, my derivative is going to be 10 times 3 plus 7, which is 37. So if I were to graph this curve and find the slope of the tangent line at x equal to 3, that slope would equal to 37. Okay, here's another one. It says find the equation of the tangent line to the curve y equals to 4 over x at the point 4, comma 1. And then we want to express the equation of the tangent line in the form of y equals mx plus b. So we're taking this one step further. So far we only found the slope, but now we also want to find the equation of the tangent line in the form of y equals to mx plus b. So first, let's just find our derivative. Okay, so we have f of x plus h. So our function is 4 over x. because our input is x plus h, we're going to replace this x with this input, which is going to be x plus h. F of x is just 4 over x. If I put it all together to get the difference quotient, it's going to be f of x plus h, which is 4 over x plus h, minus f of x, which is 4 over x, and all of that is going to be divided by h. And I'm going to write that as h over 1, so we have a fraction as a first term, fraction as a second term, and fraction as the third term. So we've talked about this before, that the easiest way to simplify this is to multiply by the least common denominator. Now the least common denominator here is going to be a product of the different denominators we have. So we have x plus h, and we have 1. The 1 doesn't really count because anything times 1 is itself, but we do have to multiply the x times x plus h. Okay, so if I do that, then, and I find my LCD, the next step is to multiply all the numerators by the LCD, not the denominator, but the numerator, because I want to cancel out the denominator. So I have 4 times x plus h, which is the LCD divided by x plus h. Then I have minus 4, this second 4 times x plus h all over x. And then I have the denominator h times x plus h. As a general rule, we don't multiply the denominator. We leave it alone. So let's simplify this a little bit. The x plus h is crossed out. We're left with 4x. And then here, the x is crossed out, so we're left with negative 4 times x plus h. Be sure to bring the negative along with the 4. The next step is going to be to distribute. So if I distribute this, this is going to give me 4x minus 4h. And then the 4x and negative 4x, we can cross those out. They add to 0. So all I have is a negative 4h over h times x plus h. And now we have an h on top, h on bottom. Those h's cross out. So we're left with negative 4 over x times x plus h. This is going to be just the difference quotient. Remember, there's a difference between the difference quotient and the actual derivative. This is just the difference quotient. So what is the derivative? The derivative is going to be the limit of the difference quotient, which is negative 4 over x times x plus h as h approaches 0. So if I do direct substitution and I replace the x with 0, I get x plus 0, which is x. And so I have negative 4 over x times x, which is going to be negative 4 over x squared. That is going to be my derivative. Okay. But we want to find the slope at a specific point, which is x equals to 4. So in order to find the slope, I'm going to plug in x equals to 4. In other words, I'm looking for f prime of 4. Remember, f prime is the derivative or the slope of the tangent line at x equals to 4. That'll be negative 4 over 4 squared, which is negative 4 over 16, and that'll be a negative 1/4. So it's just a lot of algebra here, right? Just plugging things in. And then lastly, we're not quite done. We still want to find the equation in the form of y equals to mx plus b. So the equation is going to look like this. Our point is 4, 1. So we're given a point, which is 4, 1. We're given our slope is negative 1/4. And our equation is going to be y equal to negative mx plus b. So you may remember from your algebra class that in order to find b, I have to plug in the slope and I have to replace x and y with the point. So this gives me y equal to negative 1 over 4x plus b. I replace the y with 1, I replace the x with 4. So this gives me 1 equal to negative 1 over 4 times 4 plus b. The 4's cross out. I get 1 equal to negative 1 plus b. And I add 1 to both sides. I get b equals to 2. So my final equation, slope is negative 1/4. The y-intercept is b, is going to be negative 1 over 4x plus 2. And we can check this in class on desmos.com. All right, that was a long problem. There was a lot there, so I hope you guys paused the video, copied everything down in between. And like I said, please come to class prepared with questions. All right, we're going to skip this one, so don't worry about that one. Finally, we want to estimate h prime of 9 using the table above. So remember, h prime of 9 is going to be the slope of the tangent line at x equals 9. Or in this case, it's q. It's h of q. So at q equals 9. Our input variable is q. Now to estimate that, so I'm looking for the slope here. What I want to do is I'll take the point to the left of it and a point to the right of it and find the slope in between those points in order to estimate the slope of the tangent line at 0.9. Okay, so to the left of 0.9 is going to be 0.6 comma 19. To the right of 0.9 is going to be, I'm sorry, we're going to take these two together, and then we're going to take, so first we're going to take these two, and then we're going to take these two, and we're going to average those out. So first we take the slope between 0.6 comma 19 and 0.9 comma 32. So the problem we have is h prime of 0.9, right? So first let's find the slope between these 2 points. So that'll just be y2 minus y1 over x2 minus x1, which is going to be 43.3333. Then we find the slope between these points, so 0.9 comma 32 and 1.2 comma 54. So once again, I do y2 minus y1 over x2 minus x1, and the slope between those 2 points is 73.333. Now to estimate the slope at 0.9 of the tangent line, we're going to take those 2 slopes we found and we're going to average those, and that'll give us a 58.3333. So essentially what's going on is like you have some curve, right? You have this point here, which is a point 0.9 comma 32. To the left of it, you have this point, which is 0.6 comma 19. To the right of it, we have 1.2 comma 54. So we find the slope between these 2 points. We find the slope between these 2 points, and then we average those out to estimate the slope of the tangent line, which is going to be this thing right there. So I know this was a long section, but once again, please come to class prepared with questions. Now, last thing is, in order to f prime of x, which is read as f prime of x, other notations are also used to denote the derivative. So the derivative can be given by f prime of x. It can also be given as dy over dx. So this is the derivative of y with respect to x. And it's also written as f prime. It's also written as ddx of f of x, which is not as common, but the most common notations for derivative are going to be f prime of x. So if you see that, we're talking about the derivative. If you see y prime, that is also the derivative. And then if you see dy dx, that is also the derivative. All right, see you guys in class.